Okay, looks like we're live, so welcome back. Today I'm going to be continuing to work on Kano's grid. Yeah, so hopefully can finish up the direct generation of the bytecode today. So, let's see, if I go into the build right now, we'll sort of generate two files at the moment, but obviously it's going to change. So, there's a lot of extra stuff here. Let me move some stuff here. Okay, that's a bit better. So, let's say, let's get rid of that. Let's do 12, y is 15, exit with x plus y. Alright, so if I do that, and then I run it, and let me look at my sage. Yeah, so if I run that, I expect the token. There we go. Now it'll work. Okay. So I can run that, and then echo, and that is output 27. So that's correct. And then also generated this out.tim right here, which is equivalent to the bytecode of the machine, right? Out tim and echo that and 27. So it will generate that, and then we can emulate it, right? So we generate that directly. Now it doesn't work with everything, because at the moment, you cannot do anything that requires labels. So you can't do like if x equals 12, then x equals x. Right? If you do that, it is not implemented yet, because the labels they're a bit more complicated. That's what I want to work on today. Once I get labels, then it just generates the bytecode directly, and we're all good. Then we can get rid of the assembly entirely, so we can just completely move away from that. And it's entirely self-contained, so then I'll be able to move to a separate GitHub repo. Okay. So this is in the backend. Link, right. So there's a few things we need to do here. So here's where they are at. So any jumps have that, and gen label. Actually, we create the label, right? Okay. So yeah, so basically, the label just has to correspond with an index in the instruction, right? So the instruction has to be append to it, right? So it's like inst push, inst pop, inst nope. So this would be like a label right here. And then we also have inst push again or whatever, right? And so then we'll have inst jump, and that's gonna have the operand of 0, 1, 2, 2, right? It's 2. So that would say jump back to this one, right? So that's sort of how it's going to work, right? We need to keep track of that. So we already have the label numbers. So I'm thinking we can just use an array. And then that, let's see, how do I want to handle that? So that could be, hey, Buford, how you doing? What is up? How is everything? Yeah, so basically, we have the number that goes with each label. So could that just correspond to the index, right? Because we know all the labels up front. So if we generate the label array, then we could just use that, right, for the jumps. Just whatever the label is that we pass there, that is the index. I think it could work. Making a similar project to you. All right, all right. A scripting language. Maybe I could gen label array and pass the state and the program. Okay, so if I do that, and let's see, so a few things are going to have labels. Well, let me think. Maybe there is a different way to handle this. Let's see. So where do we gen label, right? Gen label. So we generate it here. The else has a label, okay, and has a label. Yeah, so basically those are the things that have the labels. Right. Else and n. And then also we have wall label. So anything that has a label basically is what we need to generate. And the functions will as well. Howdy, how are you doing? Let me up there. What is up? So else. Right. Embedding Lua to your C++ project, create functions to create GUI layout, so you'll be able to edit UI like in Emacs or NeoVim, but in GUI. Okay, that sounds very cool. All fine. That is very cool. Do you have a link to it or not at the moment? Then creates one. Well, that uses the label number. So, well, the things that create the labels are different than the jumps. So, right. no documentation right now. All good, all good. Let's take a look. Lua editor written with unGUI that can modify itself at runtime. All right. Source. Going low level. Yes, sir. Yes, sir. Let's see. So, let's maybe look at the main. You can go to this. All right. Yeah, the main's not too much. Lua.h. All right, all right. Okay. And WM. There we go. That's where it's all at. Okay. Okay. Yes, I don't really know C++ very well. String view. Okay. Okay. All right. Editor perhaps. Learning C++ at school this year. Nice, nice. How's that going? C++ is kind of complicated. Italian, all right. Are you familiar with another language already, or is it your first language? And if so, what language? All right. unGUI. Yeah, I haven't used unGUI either. Okay, very, very cool. Yeah, I will keep looking at that, and then as it progresses, I will continue to follow it. Very cool. Thank you for sharing. Okay, okay. Let's see. So the label. So anywhere where we generate a label. Let me think. So when we generate the label, we can push it there. Right, but sometimes we use the label before we generate it, so we have to generate it all up front. Okay. We can do that. So anything that generates it. So it's fun. So wall does, and will as well, of course. And that might be it actually. Just functions. Functions might not. Backend? Well, I usually don't do any web development, so. Jump. Alright. The function declaration, yeah, so we generate the jump there, and we generate the function label. Okay. So I think I can do that, right? And I'll just DA append to that when we generate the label. So I think that'll work out. So I'll need to create a label stack in the let's see, in the program, probably not there. In here instead. So I'll have a stack of labels. So labels are really just going to be indexes, so it can be labels. And do I already have that? I have these, so I might be able to actually change that. But labels, and that's actually going to be an array of this. So right, this might already exist, and I might have that. Let's see. Yeah. Okay. What's the editor name? It is Kano. It is my own editor, text editor. Right here. That I wrote. Yeah, it's rather similar to something like Vim. I don't know if you've heard of that before. Alright, so this will be labels. Then I can just append to the labels, whenever we generate them. So, let's see. So not when we're generating the jumps, but instead when we're generating the labels. So gen label will, to state labels. Wait. Alright, so we'll append it there, because that will have the correct, index, right? And I'll still printf here, because I still want that to work. And then here as well, I think that's all of the generating of the labels. So yeah, we just need to find out where these are called, and then generate those. So in this gen label array, did I create that function? I have not. What do I have? Oh yeah, label array. So that will append it to these. All right, so that should work. That should work. So right, and it just needs to. Actually, that's not even gonna work, is it? Oh, right. because we have to generate all the instructions, so that isn't going to work. Ooh. So we need to kind of set it as we go, right? But we'll have the correct index, and then we just have to update it. Alright, that makes sense. Okay, yes, that needs to be a bit different. I wasn't quite thinking in the correct way. But we can do this, right? So we still need to generate the label array, and it's just going to append all of the labels there, because then we'll know the indexes, and we just have to modify them as we encounter them, essentially. Yes, this takes the program, state, and the program. So the program has the nodes, so we need to iterate over the nodes. This is a long switch statement. Much like this. Okay. So then in here, case type end, that, okay, Breca, and let's see, so type end, type else, type wall is going to generate one. Right. And let's see. Alright, what other one? So gen label. So yeah, gen label. So where do we call that? We call that an else. An end. And that was it. Alright, so gen func label. Gen func label. We also do it in the wall label. So that's in the func declaration, so we need that. Alright. Building a window manager 2. Perhaps. After editor. Well, not really after. Because, I don't know, I plan on working on it basically indefinitely, right? It's never done, but, obviously I get what you mean by after, though. Oh, yeah, perhaps. I'm not sure. There's a lot of potential projects. So actually, this is going to DA append to it, but it's just going to be 0. But it's going to set the index. Right. The index of it. So if it's any of these, we'll just DA append to the state labels, and we'll just append 0. Right. And then we'll have the correct indexes, which can then be set. Alright. This is really the same thing, so I can just fall through like this. Alright, and wall is not actually, so let me go to help wall. What did that generate? Gen wall. Okay, yeah, so that does. So how did that work? Alright, give me 1 second. Okay. Yeah, so that generates it like that. How does that work? So it's not constant like this one. So let me look at gen wall because I missed that one. And that does that. So that is just to keep track of it. So that's basically the index. So the index could change. That is interesting. Right, but this isn't actually going to append here. Instead, it's going to set the value. So state labels.data label. So the label is the index. Equals the current count of the state machine instructions. Yes, okay. The current count at that point. And that is what we want to say for all of these. Alright, and then label, yeah, and then this one, let's see. So I use the label, so we need to actually get the label that it uses by using the index. But then for this one, we want to iterate it in the same way that we did that. Then wall label. State wall label plus plus. What is this? Alright, so that's what we want to use there, basically. Now, is that? So we need to... not really, not really. Alright, so that should be pretty much that. Let me see. So then the jumps. It's gonna need a little work, but then the jumps, right? So gen. We need to basically create an instruction like this. And there's a jump instruction. Zero jump. And this is as in. Yes, this is in type. And we want this to be state labels, not data. That is the index that we use there. We'll need that for all of these jumps. It's just a different type. So I can get rid of this assert. And this is just a constant jump. That's generating the label. Create this as well. And func call is actually a jump as well. Well, it's a call, but it's jumping to an index. Int type. Okay, and we'll use the same thing. Okay, and let's see if that compiles at all. Those are not handling the switch. Alright, yeah, I need the default, right? Default. Search false. I reach no. Okay, we don't want to. I just want to continue actually like that because we are going to encounter that. We just don't want to do anything on the other ones. All right. Nodes undeclared. So nodes. It is program nodes. Then wall label state undeclared. All right. So we need to pass the program state in. Wall label. There should only be one or two places where we call this. So, oh yeah, just the one. So we'll update this as well. Okay. And what is that? Okay. State undeclared, so it's the same thing. State. Look at this. Okay, call. There's a few places we're going to call that. Two, probably. Yeah, okay. Array subscript is not an integer. Ooh. Oh, it's a string. Okay, yes. All right, because that is the function name. So that is actually a bit more difficult. So I will get back to that. Yeah, I'll come back. I forgot about that. So that is a bit harder to do. Well, it's not really hard. It's just we need the function. We can get the index of it. We can get the function label. Right. Okay, I'll come back to that. So I'll just do that for now. Right, conflicting types. Okay, and gen func label. Wait, what? Yeah, that's the same issue, right? So we'll come back to the function stuff. Yes, okay. State undeclared again. And that up here as well. Okay, gen jump. Then wall jump. Okay. Program state and here as well. Okay. Alright, so now it compiles. And let's see. Segmentation fault. Alright, that is interesting. Why would it seg fault? Right there. Okay, so this is incorrect. Cannot append to the instructions. Something I need to do actually. Go here and actually set the no, I don't have to. Hang on. Shoot. Why does it fail there? Gen push. Is that the first one? Let me break on gen program and then run again. Alright. Yeah, I forgot to run with the file. Alright. Seg fault. Why does it do that? Let's start it. Gen program, yeah. Oh shoot, it's failing before that. Okay, that's fine. So it's breaking in the variables. Alright, break variables. Well, let's just do generate. Run. Okay, and then I will step through this. So in here it fails. And also this is a little messed up. Gen variable declaration. And that's where it fails. Okay. We cannot append it anymore? What happened? There's something to do with this. Let's return that. Okay, so it's not that. I want to make sure. Right, let me okay, no. Yes. And it placed the same place. No, that's a different one. Okay. So wait, that was config issues. Why is that? Gen label array. Because we didn't create we did not, well, no, we don't need jumps for that. Okay, so I might have to do that different. Let me see. So alright, so what if I don't do it before, but instead I go through the program, generate everything, and then when we encounter a place where we're generating the labels, we encounter the place where we're generating the labels, and we append it, right? We append it there. So I need to think. Basically, we have to do two passes regardless, right? That makes sense. So the generating of the labels really has to be after. We can just put 0 there, and then we can get the correct index after. So let's see. Right. Let me put that whole thing back. And what I want to do is move it to after. Right, to the end there. So generate after. And instead of doing this, we'll set the actual thing properly. Right. Back out. Okay, and so what I need to do is right. We need to update the jumps properly. So I guess we have the label. So we can let's see. I don't know. Let's go to the so here, if we push a no construction, so we need that, and then we need to keep track of the index. So this is where we push the current index. labels.data. We'll append the current count. And we don't really want to append it though, but we want to set it. Right. Okay, so that's not, yeah, well, we can't do it like this anyway, but we need to set it. So it's gonna have to be a certain size already. Alright, let's see. Let me look actually in the, in here. What do we do with the labels, right? How do we set that? Size stack, yes, we have that for the labels. And what do we append to that? Let's see, so we append to the labels. Do we have other ones? So wall label. The wall labels are handled, okay, I kind of don't handle this very well. But let's see, so we set that, and we have the current labels. So we have the number of labels, aside from the wall labels. Because that is set at the end, right? No, it is not. Okay. So we just set it in. Okay. Let's see. Right here. So we set the current label, and that is basically the index, into the label stack that we need to use. That's what we pass here as well. And if we got the count of that, we could know the size, but well, here we can also do wall label. Labels. It's append 0. Well, it is less than that, and then we can set it to that. Yeah, so that will get it there, and then we can we don't have to append to it, but we can set it instead. Set the label. And then at the end, we have to go through all the jumps and set the current label based on the label stack. Okay. Use Arch, by the way. Let's go. Let's go. Another one converted. We got them, boys. Alright, actually, yes, this doesn't work here either, so I'll need to come back to that for the function stuff. So it's just this one and the wall label. Okay, I need to do this. Okay. And then so we set that, and then we can go through all of the loops here. Not here. So this, we actually don't want this. We just want the program state. In the midst of my soul, I had a feeling that Arch must solve this problem, and it did. What problem? Zero y less than instructions. Yeah. I++. And we will, if instructions data I type equals int jump. Maybe we should switch over it. Oh, with those, yeah, the GPU jump, yeah. Right. Well, that is a major W. Arch wins again, right? So switch over that, and then case of type jump. Case of type 0 jump. In case of type not 0 jump. We want to and type call. So we need to do that, but we'll come back to that. We want to set that, so we can default. Set it. Base system, base solution. Yes, sir. Yes, sir. So we want to get the index. So what we have to do is when we generate the jump, we want to append that. We want to set the operand equal to the label, and that's going to be the index and the graph. So basically, we'll set it to future information, right? Okay. So jump here as well. Just set it directly to the label. Okay, and that is the index. So I guess we don't have any in the jump, so that is a thing. Okay, let's see. So then, right here, we can set, instructions data I dot value dot magazine equals state labels dot data instructions data I dot value dot magazine. All right, and actually that's it, right? So we set it to the correct thing. So let me see if that compiles at all. It is not type. It is inst. Okay, inst. And gen label array. Yeah, so we don't need the program there. Instruction. Yes, this is a state machine instructions. My bad. Same thing. Okay. Yeah, so here, maybe I'll just set the, instructions equals state machine dot instruction. I can just use that. Otherwise, the line will get very long. Instructions dot data, instructions dot count. Well, see, I had a lot of fun and I discovered and learned so many stuff. Now I understand why Linux is called customizable. I was literally lost in the options: desktop environments, window managers, display managers, and so on. Might reinstall this thing because I've already ruined my setup. Could make it better. Yeah, I mean, installing Arch is definitely beneficial. And it's also fun, so. Ran. Okay, exit with the correct thing. So it might have worked. Alright, so if x equals 12, then we do that. Exit with x. So let's do else. Exit with y. And so there. So it's gonna exit with should exit with 12. So this one, that works. And this one also exits with 12. And if I change it to if x equals 13, which is false, run it. This exits with 15, which is correct. And this exits as well. Okay. Okay. So the functions do not work still, so I need to fix that. The only problem I didn't understand well is how to run programs within Awesome Window Manager. Well, so you have they don't appear on right click. Yeah, so, well, the way I do it is you have to set up the right keybind. Here's what the default is, but there's like this run thing, right? So I use dmenu. It's a separate one. I don't remember what the default one is in Awesome Manager. Let me look at that. I don't remember what it's called. It's like, there's a default one that is not dmenu. Let me see. Right, and basically you press the keybind and then you can run it. I think there's actually, maybe not. Basically, it lets you run a command so you can run any program. But I don't remember what it is. Let's see. Let's see. Yeah, I don't remember what it is called. Run Super R by default. Okay, Super odd. That's actually what I still use. Okay. Yeah, so you should be able to just type in the thing, right? Whoops. Type in the program that you want. Like, so what are you right-clicking it? Maybe I don't entirely understand. So again, label. Right, so this generates that, but we need to basically give it the string view name. But if we set the label for the function, shoot. We're only gonna call the label. So we set the function. Function index is when this is called, so we can use that. So we need to add that to the function. Well, I guess we don't really have it. We do have the function name, so let me think about how to do that. We basically need set the label. Yeah, because we always have the name, so we can use that. But we still might call it before, so that is interesting. You have awesome with dmenu. Yeah, that is exactly it. I have awesome window manager, and I installed dmenu instead of the default. Yes. That's because I was already familiar with dmenu, so I just used that instead of using that one. And I like dmenu, so the install also can export some programs from it into a right-click menu. Really? Okay, I did not know that. Okay, this right. Wait, the problem is that we don't know the function afterward. Function name. Let me think. So we can't do it the same way as the others because it doesn't have a label like that. Right. So how can I do that? Let me think. Basically need to generate all the function labels beforehand. So they could really be generated in... Well, no, they can't. Call X. Do you have a DE or only Awesome? I installed my DE, but I can't boot into Awesome after it. Yeah, I do not have a DE. I only have Awesome. Yes, I don't remember how I set it up. But there's like, what's it called? It's like Light VM or something like that. Yeah, the display manager. So I don't know. I don't know if you set this up already. You do have you have that. Accept your credentials and restarts when you put them. Huh. Alright, well you probably have to set it up to run Awesome. Because it was probably set up to run the desktop environment, right? So you need to configure it, to start Awesome, right? I mean, I don't remember. I set mine up 2 years ago, so. Okay. Okay, so what if I set the label? Oh, the function. So we can get the function. Function. Let's get fun. How do we get fun? Get fun. Pass all the functions, and then you pass the name. And that returns the pointer to the function. Okay. let's see, state functions and label. So that is the name, right? The name of the function. And then we can set function label with state machine dot instructions count. And here as well, we need to do that for the function call. We need to get the function. Whoops. And that is not right. Let me see. So get the function, and then we need to made an XNRC with exec awesome command in it. Okay, I'm not sure, but I do apologize. I'm actually not very good at Linux. Yeah, I could be. I just don't really change things, so I forget how all the things work. Okay, so that is what I would like to do. This, and let's see. So if I do that, and I need to modify this. So the functions. The label. Okay. Build. Is it? Seems to compile. Alright, let me run message. Let's do rule 110. Segfault. Okay, so that did not work. So why did that do that? So we get the function. We probably don't have a function. Is that what it is? Well, I suppose I could look at one at segfault. Start over tomorrow. Excited of what I can do. Alright, well, good luck. Good luck for sure. Yeah, reinstalling, it's fun anyway, so worth it, right? What is this? Where did it fail? Huh. Let's go, see, do all that, parse. Generate, step into there. Generate program. Let's see, when it gets to the... Let's just see when it fails at. Well, which it did not. The segfault's there. Oh, no. Oh, I didn't run it right. Okay. Okay, there we go. So it failed here. var.name. Why does that fail? Huh. Saying the variable name fails. That is weird. Right, this is where we're appending the arguments to it. At least I'm able to make partitions, set up a few things in my kernel, and on your own. Other stuff are just good. Yeah, for sure. That's good. You're learning. Soon you're gonna be pro. Once you can install Arch all on your own, then that's how you know you are a professional. Did I mess up that? Function args. Right, so that's not gonna work. Because obviously it's gonna make it fail now, but it's segfaults. Type. Alright, that's where it's failing now. You can call yourself not only a true archer, but a DevOps engineer for sure. You can put it on your resume. Let's see, I'm not sure how to pronounce your name. I'll say 007 followed. Thank you. I appreciate that. 007, yes. Not yeah. Why does that not work? Why do that? That's gonna break in a different place though? Yeah. It's variable weapon for itself. Why can't I send it to that? Function args. Did I break that? Why would the label mess with the argument? Now it runs. Okay, that's weird. So the position of that. Push that. Yeah, so that got messed up now. And that's seg vaulted. So now nothing. What the heck? I don't know why that one. Gen, the escape symbol? Oh shoot, you know what it is, I don't handle that one properly. So, let's see. That's in here, so escape. That returns that, but I want it to be... Right, so that's not gonna quite work. So it's not gonna work in both ways. That's fine, that is the temporary thing, but why does this fail, right? So let me actually disassemble this. And we'll output it to, out.count, sure. Out.count. I have to go pretty soon, so hopefully I can get this work. Let's see. So I can... Yeah, so this one does work. So that is, that's what really matters here. So I can now look at it side by side with the generated assembly. Which doesn't work just because of the... Well, I can make it work. So, that's that. Yeah, so this just needs to be like that. That, I think, is both actually 0. Alright, so that should work. So now if I actually... We want to know chasm. Then that works. So yeah, that was the image. So I can look at this and compare them. So if we look at this, let's go to the jump. First jump. Jump label 0. So label 0. Alright, let me actually disassemble it. Build tire. We want to know Tim. Disassemble and move that into rule.out. You basically generate your own assembly from a code just to generate even more x86 assembly. Not exactly, no. So it's a custom assembly, right, for the virtual machine. So it's not a native assembly. And then you basically that gets converted to the bytecode, and then we interpret the bytecode like how a virtual machine would interpret it. What I'm working on now is getting rid of the assembly, so that it just generates directly into the bytecode. Okay, jump 101. Right, so that is off by 1. Okay, so why is that off by 1? What about the next jump? They're all off by 1. 87, so that is off by quite a bit, actually. Okay, so that does not work. So let me look at that. As int label, yeah, let me do that from here. Send it to that. I thought your assembly assembles into a binary assembly, and instead it generates an intermediate representation. Yeah. Yeah, so it generates a bytecode, yes. It does not it does not turn into machine code. It is bytecode, yeah. So a custom thing, like it's custom thing which gets interpreted by the virtual machine. So it's basically machine code for the virtual machine, bytecode. Oh shit, I forgot to handle the call. No, I don't need that because it is different. Okay. Yes, alright, all good. So if I have a separate one for that. It's a bit So how are the calls? Call 32, so that's off by 1. Whoops. I think there's a few calls down there. Yeah, those are all off by 1. Okay, so why is it off by 1? That is a bit weird. No, it's because I generate the note first. So what if I gen label? Had to leave, 6 hours sleep, don't make me bad. Alright, have a good one. Have a good night. Sleep well. And yeah, it is good to get a good amount of sleep. Alright, I'll be back. So it still does that. Dang, it's so close. Guess his first one. Ooh, 110 has him. Like to do this. Has him. Will 110. Yeah, then that works again. Okay, so that works. Ah, shoot. I'm gonna have to handle the labels the same way I handle the labels in here. So let's look at that. So funk label or something like that. Well, so I just use the function name. But we encounter a func deck. We need to give it the label or give it the the current label number. And then the calls have to be the correct label number as well, but that's even a bit more difficult, so that's not even gonna quite work. Open that again. Let's see. Out. Out. So go there. Well, hang on. Yeah. So I need to out and open out. Now the jump is correct. Let's see. So this one is not correct. So 107 should be 87 instead. If I fix just that. Still doesn't work. Okay. Jump. The next jump is also wrong. 78. How does it get that wrong? Let me just go through all of them. Jump 100. 34. Okay. I just want to fix it so I can make sure that it's just the jumps that are the issue. How is this one off right now? 152. $146, that is correct. 133 is right. 137 is right. So it looks like it's just the 0 jumps that are wrong. 452, okay. 435. Alright, that one is right now though. 313. 330. 47. 364. 381. 398. put 15. Okay. Yeah, looks like the rest are right. Alright, that was the end. So let me try that. Is that the right one? Let me out dot Handsome and then build it on yeah. Out dot Handsome to test Handsome and then assemble it on Handsome. Build tire test Tim. Alright, so it still doesn't work. Yeah, unfortunately I do have to go. So I will commit this and I'll probably work on it off stream and get it working because it's very close. Work in progress on labels in bytecode. Alright, yeah, so it should be working by the next stream or video. Yes, that's going to be about it. So thank you guys for watching, and I'll see you next time. Bye.